Today's presenter is Lucidworks Technical Enablement Manager and Lucene Committer, Andy Oliver. Thanks for joining us today, Andy.
Thanks, Leah. Hi, everyone. So today we're going to talk a little bit about how you can use Lucidworks Fusion capabilities to create a more personalized search for customers. If this is your first time joining us, just a reminder that Lucidworks is a San Francisco company with offices in several different cities, lots of customers, including in the Fortune 1000. Our product Fusion is powered by Solr, an open source Apache-based search software. We offer support for Solr as well as for our product Fusion. Lucidworks is the main sponsor of the Apache Solr project, employs several of the committers, and is also the contributor of much of its source base. Our product Fusion 3 has a lot of, it's great to have a really powerful search engine like Solr, but if you've got data in a lot of different places, it doesn't help you much if you can't get the data into Solr. And so a lot of our customers would have to spend a lot of their time figuring out how to get data from point A to point B. What Fusion offers you right out of the box are connectors to most of the data sources where your data happens to live, a way to parse that data, because yes, it can connect, but can it transform the data into the format necessary to get the data available for search? And aside from that, are you doing a lot of really hard custom code in order to transform or connect the data? Or are you, in the case of Fusion, using more or less of a point-and-click interface to control that extract, transform, load process? Additionally, any security or any search project, any IT project really requires some sort of security to make sure users are who they say they are and that they're allowed to look at what they're looking at. And when it comes to search, in a lot of cases, you don't want to show people search results for a bunch of things they don't have permission to access. So we offer things like security trimming right out of the box for sources like SharePoint or Google Drive or Alfresco. Our product is very graphically driven, so you have a full graphical user interface for search developers to be able to test their queries, control their queries, and change the indexing process. So you could develop things like indexing processes and your own query pipelines and what have you, but the question is how would you create the kind of software that's easy to manage, easy to monitor, and that it is easy to maintain? For many companies, when they do their in-house projects that way, that's not something that's usually job number one. Get the job done is job number one. For our product, these different search components are operationally simple out of the box. So the idea here is that while we have all of these core services for natural language processing, machine learning, scheduling, query pipelines, ETL processes for the indexing process. We have tools like Apache Spark. We're built around Apache Solr, and this is all managed by Zookeeper. All this stuff is there, but from an administrative standpoint, we take care of most of that for you. You just manage your search application and control your overall search cluster using Fusion. Our product gives you a great way to be able to see what kind of searches are being done, see what the overall health of the cluster is. It gives you APIs to be able to develop your applications against, both from a management standpoint and from a search application standpoint. It gives you security out of the box that goes from both the GUI level to the API level and so on and so forth. When developing these sorts of applications, you usually want to make sure it's HA, highly available, but you also frequently need to make sure that it's DR, disaster recovery compliant. So Fusion has these capabilities built in and available to your search application and to your search infrastructure. A few weeks ago, we had the site search in an hour presentation. In that, we developed a search UI using Lucidworks Fusion. After you were done, you saw a UI that looked much like I'm displaying. That UI had indexed the Wikipedia cat breeds and gave you this look and feel. It also has type ahead, and it also uses Lucidworks Signals, meaning the most frequently clicked on cat. The most frequently clicked on cat gets boosted towards the top. So the most popular cat breeds get boosted towards the top. So that demo was based on Lucidworks Fusion 1.3 connected to Fusion, Lucidworks View 1.3 connected to Fusion 3. And it included type head facets and signals. We went over how to use facets, but then ended up removing them as the demo went on because they weren't useful for what we were doing. You can go and review that presentation at the link there. We're going to build upon this, but we're going to personalize the results further. By the time we're done here, we're going to boost, just for demonstration purposes, we're going to boost the customer's frequently clicked items to the top. We're going to find items similar to the items that were clicked as suggestions, and we're going to use rules to direct users entering specific terms. So if they enter in a term like landing page, they end up at the landing pages. So I'm going to go ahead and drop down to the demo, show you, review that demo with you, and then we're going to look at a different pipeline. All right, so as you recall, this is our search UI. We've got our cat pictures. I'm logged in right now as admin. If I could type the password correctly. So I'm logged in as admin. You can see the search results that are offered to me when I just search on everything. As you'll recall, I've got I've got the wrong collection selected. As you'll recall, I've got a query profile called cat's query profile connected to the cat's default pipeline. If I look at my query pipeline, I can see the different cats that are being displayed, and I can see that I'm using the default recommendation boosting. Last time we looked at the way that this is done through signals, and the signals show who has clicked on what. And if we look at these signals, inside of the signal, we'll see the username, and we'll see what they clicked on. All right, so if I go back to my query workbench, I've got a different pipeline that I've created called Cat's Top 10. In the Cat's Top 10, I need to switch back to my cats collection. In the Cat's Top 10 pipeline, I've set up a piece of JavaScript to get the user ID from the headers and pass that in as a parameter. I'm then using one of the pipeline stages called Solr subquery, which looks at the cat signals collection. That's where my signals are stored. The signals are when a user clicks on a cat, and I'm pulling the user ID. I'm matching the user ID against the user ID parameter that I passed in from the JavaScript stage. I'm aggregating that subquery into a list of document IDs. And then based on those document IDs, I'm boosting the results. So anything that's in that list of clicked on cats for my user is getting boosted. So if you look, this has a different set of cats showing up boosted than the other pipeline. But what I need to do now is switch my query profile. Select my cat's top 10, save that. I'll come back to my GUI, hit refresh, and now I see that the Toiger is the cat that I, as a user, have clicked on most. And you can see that there's no magic here. I'll log in as, Will Hayes. I grabbed the CEO's password here. See what cats he likes best. So he likes the bobtail best. I can also log in as one of my colleagues. And you see he likes the Bengal cat best. And this is all based on, I've logged in as these users before and clicked on certain cats and ended up with different signals for those users. Last time we actually looked at the code inside a Lucidworks view that registers those signal click or those clicks from the other side. From the client side. All right, I hooked this into Lucidworks View using the configuration that we went over last time. But I used a query profile, and if you saw, I didn't change anything to do with the actual pipeline. This is actually being ignored because I told it to use the query profile. So it's using this query profile, and I was able to switch which pipeline was being used without you seeing me do it, without me changing it in the code, essentially, or you saw me do it in the GUI in the Fusion UI, but I didn't have to switch it in my actual source code. I just switched the profile. And this is one of the great features of Fusion in that I may be testing and changing different sorts of query pipeline information, the way that queries are processed on the Fusion side, but I don't have to go recompile all my source code just to deploy a new pipeline. So it's interesting what I've done, but it's not terribly useful to just boost the top things I clicked on. Some sites do that, meaning if you've gone and clicked on a result, it boosts it towards the top. But what might be more useful, instead of boosting it to the top, and I haven't integrated this with the UI, I'm going to show you how to do it with the REST API and through the pipeline. What might be more useful is to find other results like the result I boosted towards the top of the to the top of the results. So instead of boosting Toiger to the top because I clicked on it a lot, maybe I find other documents or articles that are like the Toiger. So to do that, I've got another pipeline called cat similarity. And this is going to show an error, and I'll show you why. But in this, I've got a pipeline called recommend similar items. It takes an ID, which I'm not passing in right now. It takes an ID, and based on the ID, it gives me similar cats. So what I've done now is I've copied this published URI. I'm going to paste it into my browser. I'm going to swap it from JSON to XML because it's a little more readable in the browser. And I'm going to pass in an ID. And that ID is going to be equal to, we'll do the Cheeto cat. So I get back a response from Solr, and this time I've specified XML instead of the default JSON. It gives me information about the search that it's doing, and I find out what's like a Cheeto cat. I got back a series of different cats. I got a Bengal cat. I got a cashmere cat, and a bunch of other different results. And what this is doing is a similarity search using all of the keywords in the article, the fields from the article that I specified. So it takes I said it was the Bengal or Cheeto cat. It takes those keywords from that article and finds me similar articles based on the keywords in the article I selected. So I give it an ID. It then uses the fields from that document, and it turns those into keywords, and it says, okay, who's got the most, which articles have the most of these keywords in common? And so I get back similar results. So in your application, as opposed to doing the sort of silly thing I did for demonstration purposes and returning just the top 10 or boosting the top things that I'd clicked on as a user, you could, for a user, pick the similar articles to the ones that were clicked on and boost those instead. And there are examples of this sort of hybrid recommender pipeline in the documentation, and I'll display that link in a bit. So it's great to use things like signals and get user click events and use similarity to make recommendations to users and sort of target a user and say, hey, you like these things, maybe you'll like these things based on your previous search results. And a signal doesn't just have to be a click. It can be other things like purchases or any sort of time series sort of data that you might get back from things a user does. And that's completely just your application sending those over to Fusion, and it get recorded in a collection, and then you use those pipeline stages to summarize and roll those different results up. But that's useful. However, there are other things that are more rule-driven. So one of the other things that we have available for Fusion, it's a separate project that you can download as an extension created by my esteemed colleague, Eric Hatcher, is called Lucidworks Rules. And I'll show you a little bit of that right now. So I can go to my Fusion. I'll go to my CATS rules editor. I'll look at the rules, and I've set up a couple different rules here. One is just a redirect. So whenever a search is done, I get back a result that says, hey, go search on long-haired cat breeds. I've got another one where I've boosted the Isle of Man. Whenever somebody types long-haired as a keyword, I boost the Isle of Man long-hair cat. This is a different query pipeline. So you see here, right at the top, my landing page, based on this rule, already gives me a redirect to long-haired cat breeds. If I go ahead and type in long-haired, you'll see this link here to the Isle of Man long-hair, which is also called the Cymric cat, is boosted to the top. And why? Because that's what the rule said to do. I can trigger on a number of different things, from keywords to text to contents and what have you, but this is a really useful way to easily find things that happen and cause other things to happen in order to give you a more customized search in a way that's easy to develop. So Signals are great, and I've triggered on just straight signals, but that may not be what you want to do at scale. Instead, we also have aggregated signals. So if you looked at that signals collection, there was one document or one row per click. If I'm doing a large scale application, I've got a lot of users and a lot of clicks, then all of the signals end up being aggregated into another collection called, CATS signals AGGR, and that aggregated signal collection will have a roll-up basically where it says the article and the number of clicks and potentially the user, or in some cases not aggregated by individual user, as opposed to having a row per each click. So you get one per article or per user per article as opposed to for every single time someone clicked. So for scalability reasons, you may want to use aggregated signals. As I mentioned, there are different recommendation signal data sources or different signal data sources. We did click-based, so users searched on something and what they clicked on. You can also use the aggregated signals, as I mentioned. You can also use additional sources. So in some cases, you may want to only boost things that are similar to things the user actually put in their shopping cart. So you could say, okay, the user added the tabby to his shopping cart. I'm going to boost things like the tabby. It doesn't matter which things they clicked on. We're only interested in what things they stuck in their shopping cart, or only things they actually purchased. Or we might go the other direction. Hey, if they even hovered over it for a little bit, we'll give them information on it. There are other types of things like geolocation data that you could, the user was near here or what have you, that you can use signals in order to improve your search based upon. There are different types of, I showed you one similarity type. There are different types of recommendations. So I showed you a recommendation based on content, so how similar two items are. There are other types of recommendations that you may want to consider in your search-based application. Another would be clustering, so how well two things go together, or collaborative, which is what I showed in the search in an hour, which is how other users liked it. In this case, I based on on them clicking on it. You could also do whether they started or liked it or what have you. You may also end up doing a combination of these things. Why would you do a combination? Well, one of the reasons would be for a cold start, meaning a first-time user comes to our site, we don't know what they've clicked on because they haven't clicked on anything. We don't know what they like because they haven't clicked on anything. So what we might do is show them boosted results of what other people like, the most popular items that are relevant for their search would get boosted to the top. And then once they start clicking on things, then we find them similar results to the things that they clicked upon. Or we might find them complementary items to the things they clicked on, things that go well together. If you bought these shoes, maybe you'd like this belt, things like that. This is my mostly accurate, simple explanation of clustering. And this is used in finance, it's used in retail, the list goes on. In the case of finance, things like offer management. In the case of retail, product recommendations. So I picked some characteristics, and these may be your purchases. They may be, in this case, I'm showing demographic data because I was thinking of finance. And so I've got some people that are above the age of 60, so some sort of range, 60 to 70. They're different genders. They're all in the income bracket above 100,000, and they all have, some of them have master's degrees, doctorates, some are just high school, some are bachelor. And then I've got some other folks who are different age ranges or different income brackets and so on and so forth. So for my clustering algorithm, which will usually be an automated machine learning sort of thing. It doesn't have to be, but it can be an automated machine learning algorithm. It goes and says, okay, these are the people that are close together. It decided that people in the 60s with these income brackets are one cluster. It decided that the people below those ages in this other, or in this case, there's similar income bracket, but looks to be slightly higher on average. But these other people in this other income bracket with these other ages are a different cluster. And so now we're looking at the different things those people have. And we're saying, okay, this person has a money market, checking, IRA. This other person's got money market, credit card, checking, IRA, money market and checking, checking and IRA. And to a large degree, these sorts of recommendations are, how do we make these people more alike? So one guy or gal in this had a credit card, but no one else in that group did. So we didn't make a recommendation based on that. We made a recommendation based on the common stuff between them. And what we decided was that that IRAs and money markets are the things that the two people on the right were missing. And so we'd say, hey, would you like an IRA? Other people like you have IRAs, or other people like you have money market. This is sort of a two-stage sort of clustered recommendation. In some cases, we would do just clustering like documents or what have you together, but we can also do clustering like users, which would also be stored as a document, and have a subsequent collection that that is associated with those users, and that's what I'm demonstrating here. So when it comes to customer-targeted, personalized, and these machine learning algorithms, we'll be talking about them more and how you use them with Fusion. But there are capabilities within Fusion to use these sorts of machine learning techniques. And that's part of why we have Spark as part of Lucidworks Fusion. So for customer-targeted personalized search, a key piece of this are the signals, recommendations. Some of those recommendations are based on similarity. A lot of what we do is based on rules. So, gee, if you type in this sort of term, maybe we want to send you here. Clustering and things like that can be done with machine learning. And these are all things that are part of Fusion that you can use. So what are the sort of next steps? So we gave you a basic idea of the kinds of recommenders that are available. We started out with the basic collaborative where users clicked on things, so those things got boosted. We went and got a little bit more personal. You clicked on things, so those things are boosted. We talked a bit about similarity, so we could take things that are similar to the things that you clicked on and recommend those instead. We talked about hybrid recommenders for when you've got a cold start. Gee, we start out with what's popular, then we go and recommend things based on what you liked. So the next step, you might want to look at the Fusion documentation, which gives you a example pipeline for hybrid recommenders and shows you how you can use those in your applications. In Fusion 3.1, we've got new recommenders that are coming, and we'll be talking about those more as the weeks move on. And then you may want to start looking at pattern recognition and prediction. So based on your signals, based on what users have clicked on, based on what they've purchased, based on what they like, we pick different. We predict different things that they may purchase in the future. So there are different machine learning algorithms that can do basically purchase prediction. So at this point, we'll take some questions. I wanted to note to you guys that this is sort of the last in a series of webinars that we've done. We started off with the Fusion 3 overview. Then we talked about site search in an hour with Fusion. And then we had building conversational search. And this is building customer targeted search. Are there any questions?
Hey, Andy. Yes, we do. We have one question. Are you hearing an echo?
Only when you talk.
Okay, I was hearing it too. Do you still hear it?
It's okay.
Okay. So the question that we have, and For the audience, you can continue to enter questions in the chat box if you have any. So, how would you merge standard recommendation boosting or boost factors with these personalized results so that you can get personalized results at the top, but still get popularity boosting for the balance of the results?
Okay, that's a great question. So if you look at the signals and recommenders page that I referenced, in here they've got a pipeline, and of course when I go to bring it up, it's either changed or something here. Let's see. Okay, well, if you look at the signals and let me bring up recommendations. Okay, here we go. In this URL for, if you go to recommendations in the documentation, they have an example pipeline which does essentially just that. What they do is they've got first they check for user recommendations, user-based or personalized recommendations, and if those fail, then they go ahead and boost as a second roll-up default recommendations. And this comes down to a combination of your boost levels for those different things in your pipeline, or whether you skip certain stages based on whether or not there was a user logged in, or whether or not there's you know the user. So whether or not you know the user, or whether the user's been here before, in addition to what data you have for all users. So you can combine these together and then basically order them in the pipeline and manage the boost level so that your personalized recommendations have a higher boost level than your general user population recommendations.
Thank you. The next question is, what is the user ID? A cookie value set on the user's browser, or an explicit ID of an authenticated user?
So that's up to you. In this case, I actually used an authenticated user because I had one and I didn't really have a cookie value, and that would have been really difficult to manage. It was easier with Lucidworks View out of the box to just log in and log out. So this is actually doing basic authentication in the browser, but you could just, it could be something as simple as a cookie value or a tag, tag equals whatever, a tag. So you could do any of that. That's up to you. You can get any of those with Fusion by just reaching, I did it with JavaScript, just reaching in and grabbing that from the request. So in this case, I grabbed the header. The user ID was a header, but you could have grabbed it from a cookie. You could have grabbed it from whatever you like.
Thank you. The next question is, how do you expose user attributes to Fusion so that Fusion can drive clustering decisions?
So those are passed in. Either you can pass them in by setting your own cookies or passing those through. In general, you're going to pass them on the query string.
Thank you.
You also, in the case of authenticated users, Fusion can authenticate and participate in SAML, LDAP, Kerberos, and so on and so forth. So you can, say have LDAP users or what have you in the case of authenticated users. For your more e-commerce type applications, you may not have that, so you may be doing more cookie attributes and then passing them in as on the URL or as headers.
Thank you. And then from the same person, how is a body of knowledge developed over time in Fusion? Does Fusion index users and their attributes?
You can index, a collection can basically store any kind of document you want. The default, and what we went over last week was composing an actual signal request. In that signal request, I just had the field that that I showed a second ago. Oh, wrong collection. So if you look at the CAT signals, inside of CAT signals, you have different users here. So inside of CAT signals, you have the username, you have what they clicked on and whatever. This was all passed in from the application. So I could have passed in any kind of information I wanted as part of my signal. I might also have another collection with just user attribute information, or I might have that in the ancillary system. That's really up to your application as to how you want to do that. Do you want to store them in Solr as a collection, or do you want to store them in some ancillary system? So if you've got an e-commerce suite or whatever that already stores that information, then that answers that. If you don't, if this is a core piece of the, you can basically think of Solr, the backend of Fusion, as a document database. So you can store that information there if you would like to.
Thank you. The next question is, how would signals work with other tools like rules? If rules boost 3 products and signals boost others, are all boosted?
Yeah, so you can have a pipeline that has both signals and rules in it and combine them together. So you can have rules boost some things and signals boost other things and combine them in one pipeline. So you can use them together in that manner.
Thank you. So those are all the questions we have. If anybody has additional questions that you didn't get a chance to ask, feel free to reach out to us at events@lucidworks.com. Everyone who registered for this webinar will receive a link to the recording shortly. Again, if you asked a question and for some reason we missed it, look out for a note from the Lucidworks team. And thanks again for joining us today. Thanks, Andy. We hope everyone enjoyed the webinar and has a great day.